this column, write down your notes. But then afterwards, go ahead and break it down for me. And what I'm asking you to do is go ahead and actually give me the answers for the OPS acronym in regards to this column. I want to know the answers, and what I'll do is I'll call them somebody randomly. I want you to be able and accurately come up with the different components required to graph. And we're actually not coming up with all the components, just the basic ones that will be required to graph. Good. Hey, listen, let's bring some excitement. Yeah, right here, right before I click on it, see if it's you. I'm going to hold it for a second. I know, right? There you go. 24. All right, so in this case, it's actually Dennis. It falls on you. What did you actually come up with? Yes. Yeah. So O is -2. So that's the first part of the acronym. Yeah. Yeah, I think y'all were maybe making a little bit more. Yeah. So here's the O. Yes, and then what else? Yeah, the A will be 4. Okay. The F would be 1. You know what? I think you were trying to change it because you said the F would be 1. In this case, you had the right idea that you had to factor out, but in this case, you would factor out a 2. If you factor out a 2, this here, let me make it in red so it could be important. You'll be left with x minus pi divided by 2, which means that, remember, this is what I was talking about the previous slide. The important part that we had to take from it is that and I'll move for a second, that the F had to be in the outside parentheses, which means that this is actually, oh, hold on, let me keep black. This is actually the F, and my starting point is actually going to be not negative pi over 2. Because remember how with functions, the h value was opposite the transformation, like if it was negative, it would move to the right instead of moving to the left. So that actually represents a starting point of pi divided by 2. So that is important to know. All right, lovely. Now we have our 4 major components, and to start graphing in, we're going to go ahead and do the setup. The setup is the 3 horizontal line with the 9 tick marks. So here's the initial setup, and then we'll continue with graphing this cosine function. Now, a delightful part of it is that I know S. Actually, let me give you a chance to draw your 3 horizontal lines, the 9 tick marks. All right, good. Okay, so I know my starting point. My starting point, as we said, is pi divided by 2. Now, one of the reasons why we start at the starting point before moving to frequency is because the frequency is going to depend on the starting point. Now, before we take the starting point in consideration, let's go ahead and talk about the frequency. The frequency is going to be, in this case, 2. And the frequency contains 2 subsets. The first one being the period. Yes, 2. The first one's the period. And the period's going to be found by using our equation 2 pi over f. Yeah, and the reason why we select that is that sine and cosine don't repeat values until we reach 2 pi in the unit circle. Which means that because of that, I'm going to end up having 2 pi over 2. When I have this kind of fraction set up, I discovered that the 2's actually divide out and just gives me pi as the period. Okay, so this is good. It's lovely because it gives me the ability to now put in the center a cycle. I'm not all the way done. Now, if you wanted to find the ending, you can multiply by 2, but I'm not going to do that in this one. And the only reason I don't, you can, I'm not, because this is actually, the frequency is partially going to depend on, or it's going to move because of that pi divided by 2. But before I get into that, let's go into the next subset. The next subset is scaling. The scaling portion, or the scaling aspect of this, involves the use that you're going to take your period and you can divide it by 4, or you could think about it as your period multiplied by 1/4. What is important to keep in mind is that the 1/4 is designated as a way that we chunk it. We're chunking it in smaller pieces. That's the reason why. So the 1/4 is a given. It's not like you come up with it. It's just that one of the things you have to accept and remember as part of the answer. So in this case, my scaling is going to be pi divided by 4, given that my period is pi. So that's easy. What I like for you to do is now the next 2 that you're going to come up with is the axis of oscillation. The next 2 you have to find. You know the values, but I want to know your results. Come up with the results for the axis of oscillation and the amplitude. And I'm calling somebody randomly. Because it works as the H inside of the transformation, and where it does the opposite. I don't know if you remember, like when we had x minus 2 squared, it would move the parabola to the right. You are going to go and you're going to find the answer for the axis of oscillation and the average. I need to know the results. You have values, but I need to know the answers. Those values involve, one of them is really easy. The other one's easy too, but it's just be careful. All right. Let's see. Let's bring some more. Yeah, or suspense as well. So right before you hit generate, you have to know: will it be you? I got this. I got this shit. All right. Nice. All right. Hey. Okay. Now, so what'd you go? What did you get? Actually, that's good for the axis of oscillation, but it should be -2. Is that what you wrote down, or? Yeah, if you wrote down -2, then that's right. That's good. That is that's the right solution here. So the oscillation, the O, is y equal to -2. So let's go ahead and put that down. Y equal to -2, but we also need to, so this is the oscillation. And it's actually the reason why it's important is that in our 3 horizontal line, that's the midline. That's the one that goes in the middle. Now, what about the amplitude? Well, it's, hold on, I'm hearing a whole lot of things here. Okay. First of all, tell me, what is the actual A value? 4, right? Okay. Now, what do we do with that? Well, actually, in general terms, you're going to think about it is that you're going to take your y, take your O. I'm not writing down 0. I'm actually writing O. O plus your axis plus your amplitude, and also your oscillation plus your amplitude. I mean, not plus, minus in that case. O minus your amplitude, which means that you're going to take your value of 2 and add 4. Oh yes, -2, and take -2 and subtract 4, which means you get +2 as one of your answers and -6. So you're right, Ethan, about the -6. But the did you say 2? Yeah. Oh, I didn't hear the 2. I did hear the the important part was everything else, the art behind it, because it's not. Yeah, the numbers will change. Now, the reason why all that was important as well is just because these are going to be the values that we're going to place on our three lines. We're going to have +2. We're also going to have -2 and -6, which means that this trig function was just translated down. It would just move down. Now, we now have to start with the scaling, the everything else. Now, one of the lovely things is I do know that this is pi divided by 2. That's my starting point. What sometimes becomes a little, not confusing, but it takes some work to get is that, okay, if that's pi divided by 2, and let me draw a little unit circle here. We're not starting at 0. I'm actually starting, okay, do y'all recognize that that's where pi divided by 2 would be at in the unit circle? Okay, what would happen if I added a pi divided by 4 to it? Isn't a pi divided by 4 a 45-degree angle? Yeah, so what would that be on the unit circle? 3/4 pi. Yeah, if you have the unit circle, please bring it out because you will need it. 3/4 pi, which means that this value that is here is actually this little next tick mark is 3/4 pi. This is how it looks graphically. I just showed you a graphical representation of what the adding pi divided by 4 to pi divided by 2. Let me do it algebraically. Really, in essence, what I did with the unit circles, I took pi divided by 2 and added pi divided by 4. Now, just looking at this, we know we can't add that because they're not common denominators, but I'll make the pi divided by 2 into a common denominator by multiplying 2 top and bottom. With that, I'll be able now to add them. This is just 1 that's there, which means that this becomes 3 pi divided by 4, which is the same answer that I came up with graphically. This is the algebraic way to do it. Algebraically, all you do is get a common denominator. Now, with this, I am going to add another pi divided by 4, which means that this is next 4 pi divided by 4 pi, which would make sense graphically because I'll be adding another 45-degree angle on, and then I'll get to pi, wouldn't I? And then after that, this becomes 5 pi divided by 4, 6 pi divided by 4, 7 pi divided by 4. Now this 6/4 pi, if you reduce it, becomes 3/2 pi, which means that you would get here already. We would actually pass the 2 pi marker because we moved everything by 1/2 pi. And in addition, this will become 9 pi divided by 4. And finally, this will become 10 pi divided by 4, which reduces to 5/2 pi. You may not see it, but the if I took pi divided by 2 and multiplied it by, or actually not multiply it, if I added it to 2 pi, I would get 10 pi divided by 4. Because remember, I require 2 of these cycles, which means I need to add 2 pi to that initial start value. Now this is good because it gives me the complete setup to now draw my cosine function. But in order to draw a lovely cosine function, I will need to still reference back to the unit circle. And what I mean is that a cosine follows a different path than would be a sine function. Now, if I drew just a unit circle here and I drew the extremes, okay, this would be 1, 0, and 0, 1, 1, 0, yes, negative 1, 0, and then 0, negative 1. And I'm going to go ahead and ask you, like if I ask you what is the cosine of 0, or this first one here, what would you all tell me? 1, right? Okay, so it's going to be at its highest value, which means that we start there. So you're going to start your dot there. You're going to start, that's the reason in your notes, you went ahead and wrote down, you start at the top with the cosine. Now after that, you look at the next value, the next extreme, which would be this one, and the cosine value for that, 0. So that means you actually would now hit here in that place. And then the cosine value for the next, which is a pi, would be at, so you would hit here. And then the next one would be 0 again. And then finally we'll go back to 1. So a cosine will actually follow this kind of path. Slightly different from a sine function. So we'll go up and go down, and then after that, it will repeat. It will repeat in where we're going to draw the second cycle with the exact same pattern formation as the first one. It's actually very similar to a sine function just moved. You got to remember that those triangles, we interchanged the x and the y's. There's no way we just moved them around, which means that we're related just in different times and positions. So that's the exact same thing that appears with these trig functions. But at least the grand finale is done with the cosine. It's done. All right. I want us to now practice the tangent because the tangent is a little different. With the tangent, I'm going to go ahead and start writing offs on top, and I'm going to write down f of x is equal to the tangent of x. But I want to go ahead and challenge you with the same request. Convert this into the offs acronym. Expand it, add some of the identity values to it, and then I'm going to call in somebody randomly. Again, mostly identity values. back the suspense and the thrill. It might be you. Well, she's actually it's 9, 10, 11, 12. It falls in between Dylan and Paula. Give me either one of you to answer this question. Is there one of you that actually came up with the answer? Either one. We got two minds here. It's all right. Now you're probably not the only ones. There's more than one. It involved it involved adding some identity features. The 0 at the beginning. That's the O. Oops. The 1 to represent the amplitude, the tangent, and then the 1. Now, if you're going to do this properly, correct, I mean, like in the best way, you will do 1 and then the x plus x or minus 0. I'll just do minus just because it's always opposite of what it is. And so this is your F, and this is your S. There's a reason why. The reason why I did the parentheses is just because it accentuates and highlights the importance that if there is an F value, then it must be factored. It needs to be on the outside. So from here, I will let's do the setup of the 3 horizontal lines. So 3. The 9 tick marks. And we're set up to graph, at least initially. Now, what is lovely is that the starting point is 0, so there's really nothing extra I need to do here. The frequency will be f equal to 1, but I want you now to come up with the result of the period for this tan function. I'm going to call in somebody randomly. Hey, let's have some fun here. Let's see who gets big. All right, 21. Let's see, 25, 24, 23. It actually falls right between Daniel and Seth. It could be either one. You are 25. Yeah, you'd be 25. So that means either one. Either one of y'all came up with it? It actually the answer would have been pi. Yeah, well, the answer would have been pi, but that's because you got to remember that the tangent function is one of the trig functions that does not start repeating values until you actually hit pi. And I can show you here. Let me show you. We talked about it yesterday. But if you look at the, let me highlight them for you. But if you look at the actual tangent values, which is this one, this one, this one, this one, that. Oh, it's not that. If I can do that. No, I can't undo it. But I could erase it. There. This one, and this one. You'll notice that I go back to 0 again at pi. So that's when it starts repeating again. Because look at the values again. This becomes the square root of 3 over 3, which is right over there. And then 1 again. So that's the reason why with the tan function, it will start to complete a cycle only requires pi and not 2 pi. Which means that it affects graphically that, and that's the reason why I wanted to ask it. I wanted to highlight the point that with the period you have to do pi over f and not 2 pi over f, which means it would be pi over 1, which means it's just pi. Okay, lovely. Okay, now the scaling. Oh, because the sine and cosine are, no, the sine and cosine in the unit circle do not start repeating values until you go all the way around. And that's the reason why. That's the reason why it has that feature. That with sine and cosine, we must use 2 pi over f, as opposed to tangent that repetition of values do not happen until we hit pi. So the scaling of this is going to involve us taking our period and dividing it by 4. That does not change. So it's going to be pi divided by 4. So that's lovely. Now, as far as the axes of oscillation and amplitudes, those are going to be easy to find because, first of all, oscillation means that in this tan function without anything on it means that y is equal to 0. That's going to be my midline. My amplitude, which is a equal to 1, means that I'm going to take y, the 0, add 1 to get 1, and I'll do y 0 and subtract 1 to achieve -1. So we will get the results of 1 and -1 for amplitude. Everything's great because I have all values necessary to generate everything that my graph requires. Other than the graph itself, other than the points that actually lie. I'll give you all a second to finish writing. Yes. 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 So when we go about to actually graph this, we'll go ahead and 1, 0, -1 will be the 3 lines, and then we'll start scaling the tick marks. Remember, we start with 0, and since we start at 0, it makes it easy because this just means this is pi divided by 4. This is 2 pi divided by 4. 3 pi divided by 4, 4 pi divided by 4, 5 pi divided by 4, 6 pi divided by 4, 7 pi divided by 4, and finally 8 pi divided by 4. That would make sense because for a tangent function, it'll take two pi's in order for you to make 2 cycles. So that's it. Now, I'm not gonna. You don't have to reduce when you're doing this. Because I know you're probably looking like, I need to reduce 4 pi, not necessarily, because you're using it as a numerical number and so I'm not going to take any points off of that. Now, what I will want, there you go. All right. What I will like is for us now to actually graph the tangent function. Now, this is going to be unique, and it's going to be actually interesting because we're going to start the same method, the same way we did before. We're going to analyze tangent at 0. At 0, it's 0, right? So that's the reason why it has that feature that it starts at the midline. So my first mark will be here. And then I'm going to go ahead and look at it at pi divided by 4. So when I examine it at pi divided by 4, do you notice how it's 1? Which means that in this case, it'll be 1 here. So everything's going good. This next point is what makes the tangent function interesting. That when I look to see what is it at pi divided by 2, I have a word that's up there. It's undefined. Now the reason being is because it's y divided by x. If I took 1 and divided by 0, I would have an error. I have something I can't do. How does that show up on a graph when you have something that's undefined? Well, we have a special way to mark it on the graph. It's an asymptote. Yeah, an asymptote is the way that we mark something that's undefined, which means that on this trig function, we're going to make an asymptote right at pi divided by 2, or in this case, yours is marked off as 2 pi over 4. Now, that's not the only place that we're going to have an asymptote. Remember, this being a trig function, it's going to keep on generating asymptotes over and over again. But since we're only doing the purposes of our 2 cycles, we're also going to see it at not only here, but also right here. Y'all see how it says undefined down here? So also at the value 3 pi divided by 2. Which means that in our trig function, where it says 6 pi divided by 4, we're also going to have an asymptote there. Now, it's this asymptote that is actually going to make my trig function have this quality that it's going to shoot off in this direction as it approaches. And then I'm going to find out how to graph it by, once I look over the asymptote. So at 3 pi divided by 4, I'm going to look at that value on the unit circle, which is here. Y'all notice how it says -1 here? Which means that here it's going to start down way over here. And then at pi, which is 4 divided by 4 pi, at pi, I look at the tangent value on that, and it's back to 0. We actually completed a cycle once we hit the pi, and all the values are going to repeat, which means that this will be 0. It's kind of like I'm starting here. The next value will be 1. And we could actually reference back to the unit circle. Like if he's like, you know what, I'm not exactly sure if that would be 1. Let's go back to it. You'll see it. It says 1 there. Once you have that for sure defined, this tangent function then is going to look like this. And then again, we're going to start 7 pi divided by 4 is a -1. And then it's going to go back to 0. So it's going to have this quality. So this is what makes the tangent function interesting, that it includes asymptotes as well. Okay, this is lovely. All right, now what I want you to do is I want you to take the next couple of minutes that we have and actually work on the classwork assignment. I am going to have you try it out for like maybe 10 minutes by yourselves before I can get into it. Now you got a couple of questions here and there. So the best way for you to learn is to try it.